Thank you. So, good morning, everyone. My name is Emanuele Alsina. I'm advised by the Professor Cabri. My research consists in develop models to manage the complexity in industrial and dynamic environments. As you can see, it's a very wide topic. So in these 3 years, I developed several models that I divide into 2 areas. The first one concerns the management of the complexity. Here, the focus of the models is to introduce a new approach for the problems. The second area is related to the prediction. This is also an outline of the presentation. I will briefly introduce all the models that I developed. The first model is related with assembly line. Assembly lines are a set of workstations where parts are added into the flow until the end when the product is finished. Some examples are related in the automotive field, but also for the assembly of electrical components. And it's not so common here in Italy, or it's not common at all, but in the US, for example, in some places assemble your own meal. Some very famous food chains. The problem in assembly line is the balancing problem. It assigns to its station a group of tasks, respect some constraints. We focus on the time and space assembly line balancing that considers space limitation and time and space limitation of the components. In our model, we added also the peaking time of the components. This because, especially in the automotive field, the components can be very big. So, depending where you allocate the components, can be different the time of the task. We developed a mathematical problem. It works. So, that's it. In reality, if you increase the number of tasks, the components, and the station, the computational time to solve this, all these equations increase exponentially. So the problem is NP hard. So we developed a model that finds a suboptimal solution. We decompose the problem into 2 phases. The first phase assign the task respecting only the time constraint. We use the beam packing problem to do that. Was already used in literature. We can see some example with 4 stations, and all stations have a different task. Then we optimize the allocation of the components in different areas. We propose 2 different approaches, one with genetic algorithm and one with genetic programming. Both of them have some pros and cons. For example, genetic algorithms, the cons is the exploration space because it optimizes just the task within the station and doesn't consider the exchange of tasks for the station. Okay. The second model was related with the production line. They are very similar to assembly line, but in each station here there are machines that work, so do some work. And the problem here is to find the production rate of the line that is related with the failure prone of each machine. So we developed an agent-based simulation that consider different characteristics of the machines, like an aging and degradation, but also some events that can happen in the production line, like repairs, replacement, and preventive maintenance activities. The agent, the idea, the novel idea was to divide the complexity of a single machine in one agent and the complexity of the line in different agents that coordinate all the behavior of the line. It was really useful because there wasn't in literature a model that considered all the characteristics and events together in the same model. The third model was related with the planning in public transportation. The idea was to define some schedules. It means define departure times of buses and vehicles and drivers. It was a really application. We applied this model in the city of Buenos Aires in Argentina. It's a very known problem, but the typical solutions are not applicable in South America because of the dynamic of the environment and the reliability of the data, if they have data, because not always they have data. So the idea was to have a very flexible model. We developed, one more time, an agent-based modeling inspired by the ant colony algorithm. So the model creates schedule in probabilistic way, then evaluate the schedule, leave the pheromone. It means that the other iteration of the model consider the best schedules in the previous iteration, and then iterating the process several times, the model arrives to one suboptimal solution. So the improvement was the flexibility. It was the first good thing, but also the model, we defined some indicators of the solution, and as we can see, the frequencies of the models are similar to the desired frequencies, or the use of vehicle, and the waiting time of the buses. The last model of the management area is related with the automated warehouses, where there are automatic cranes that satisfy storage and retrieval requests from specific location in warehouses. The idea here was to introduce a new approach for the adaptive manufacturing. There are several policies in this case of define the dwell point of the crane. It means the point where the crane wait to satisfy the next request. And there are several policies that are very straight. It means, for example, you have to wait in the middle of the rack, or in the input point, or in the last location. But we believe that the location depends on several factors. So maybe if you have a lot of requests, the optimal point can be one. If you have a big warehouses, the dwell point is another. If you have the small warehouses, it's another. What's the optimal point? We don't know. So we have to develop a model that autonomously understands where is the optimal model. With the optimal point. We define the model that consider the request, and the request attract the dwell point like a center of mass. And the results were pretty good because respect the models, the policies already used, the travel time, our model is the second. And for the wait time, our model is the best. It means that the system is more lean. It's more ready to respond to the request. Moving towards the prediction, we developed some models to predict the reliability of the failure prediction of mechanical and electrical components. The first idea was to understand the performance of artificial neural networks. The idea was to define some very simple networks because it has to be used by manufacturing men that are not computer scientists or mathematicians, so they have to use a very simple models. We understood that even very simple networks can improve the prediction accuracy by an 8%, more or less on average, compared with the traditional approaches, the more used approach here is the weighable distribution. And then we study the performance of other advanced models taken from the machine learning or soft computing, like support vector regression, neural networks, random forest, and fuzzy system. We found that random forest obtained the best average result, regardless the components. Then we studied the solar radiation. We predict the solar radiation in several Italian places with the artificial neural networks. It was already done in other places in the world, but was the first time in Italy. It was like an application model paper, but we found that the error was better between 1% and 4% respect ARIMA model. Another interesting model was to simulate the demand in a smart city, and we developed a model that predicts the energy demand of the day after. The agent communicates with the web services in order to understand in order to forecast the weather of the next time, then optimize the exchange of energy between producers and consumers in a smart city. The last part of my research focuses on the social interaction in online communities. We study the user behavior in a network of question and answer communities, where user can ask questions, get answer, and so on. The idea was to define some characteristic of the user that have a correlation with the success of the communities. So for example, at the beginning we focused on diversity measures, so we defined some success measures. So what is success in this kind of communities, and what is diversity in this kind of communities? The idea was to find some correlations. So for example, here we can have that in non-technical communities, the diversity in terms of tenure, so newers and veterans, are correlated with the success of the communities, but it's not true for non-technical. It means that, yes, it means that in technical it's not true. It means that when you talk about non-technical topics, it doesn't matter if you are a newer or a veteran in a community, but when you talk about technical topics, it's very important to be an expert of the topic. With this kind of ideas, you can, for example, predict the quality of the success of the community, looking at the characteristic of its users. Another study was related with the bounded rationality. Sometimes constraint of time, motivation, or even cognitive capacity can limit the effort of that the user invests in evaluate information. Evaluate information is costly for the brain, so sometimes we use like shortcuts to make decisions. We call that the heuristic. So maybe sometimes we can evaluate better the first answer or the last answer, regardless the quality of the answer. So for example, we study the chronological order versus the acceptance, and we see that the probability of the answer to be accepted is higher in the last answer. It makes sense, because the last answer, if you want to produce a good answer, time is required. It also the users who posted the last answer also read the other answers. So it makes sense that the last one have a highest probability. But as we can see here, here is the probability of the last answer minus the probability of the first. The black line is 0, so if you are above the line, the first answer, the last answer has more probability to be accepted than the last. If you are below, the first is higher. The first answer has higher probability. So it means that when you have a lot of answers, the first answer has a higher probability to be accepted. So when you have a lot of answers to evaluate, you prefer to select the first one, because read all of them require a lot of time and a lot of effort. So we developed some models to understand which kind of characteristic can be related with the choices of the users. We use a logistic regression with some anxious parameters to understand if the users use this kind of heuristic to accept or not answers. And we can see, for example, that when we have a lot of answers in a thread, the score share of the answer is really correlated with the acceptance, for example. Another study, here, for example, in this case, you can predict the acceptance of the users regardless the quality of the answers. So it's pretty crazy. Another study is related with the answer length and the probability to be accepted. We can see that if in a day I post different answers, the length of the answer decreases during the time because I get, because it's costly, so write a lot of long answers require a lot of time, but the probability to be accepted is high. It means, for example, that we can predict the probability to be accepted. For example, I can predict how good you will be in a test just looking in the length of your first answer. And it's really interesting. Here there are my publications, and that's it. So if you have any questions.
So we have a time for a single question, if you have, okay.
Very interesting set of application, but an observation. You have to get the title, so you don't have to say we or say Cabri is getting the title. You know, it's very important because we are evaluating your work.